Hello, my name is David Vi. I am a Senior Product Marketing Manager with Cadence Design Systems. And today I'm going to be talking about new enhancements to our network synthesis capability in AWR Design Environment version 15. The new capability allows engineers to develop impedance matching networks for MMICs or RFPCB designs to synthesize those networks with process design kits or components from our vendor library. So let's check out these new features by launching the software and looking at the network synthesis in a live demo. From this project, I've launched the network synthesis wizard from the wizard tree in the project manager. Those familiar with net synthesis will recognize the 6 menu tabs along the top. The tab shown here is the synthesis definition window. There's a pictogram indicating the matching port numbering that is used to define networks and their port definitions. With this tool, we can perform impedance matching, interstage matching between two complex impedances, matching for noise figure and load pole performance. We can define the impedance, which is defaulted at 50 ohms, define the impedance at port 1 or port 2. We specify the frequency. Automatically it takes the frequencies from the project, but we can override those. But it does make sense to use the frequencies, especially for matching to load pole results. And then we select the component tab. We define the topology, which is the number of sections to the matching network, and a nice practical capability to the network synthesis is the ability to define the first and the last component. So like if we had a surface mount component with a lead, it makes sense to have facing that surface mount component to perhaps be a transmission line to accept the lead. Now the change in V15, where before in the first release we just had ideal components in either a shunt or series configuration, we've now added the ability to select components from the vendor library, and if we select those components, you can see that the library tree is taking the same libraries that are loaded into the project and all the various components that have been loaded in this library. And we can go down and we can select, say, based on a manufacturer and a particular type, say package size, and select the values that we want, and then add that to the collection of components that are available for synthesis. We can also create files of component types that we intend to use for a particular design. Perhaps maybe we revert to using 0402 or 0603 size packages for different design types. So we can configure different files that refer to the components. And in this case, we're loading up a library of capacitors, inductors. We could add resistors, but in this particular case, we have no resistors defined. So now that I've loaded up the available components for synthesis, I select OK. And then I could set parameter limits, and in the previous version, when I was dealing with ideals, I might have put in parameter limits for the ideal components. In this case, they'll be limited by what I've selected for component values from the libraries, but I can still set parameter limits to my transmission lines so that I ensure that I don't exceed a width or a given characteristic impedance. I can also insert a bias feed network and define these parameters. I'm not going to go too deep into this because we just want to talk about the new features in version 15. So moving on to the next panel is the goals. This is largely unchanged from the previous version of the network synthesis. And the top is where we select and define our synthesis measurements. In this particular example, we're setting our goals based on load pole, aligned load pole information shown through this panel. And this particular measurement is for our power additive efficiency aligned to a 3 dB gain compression aligned to the center. Our second goal is based on also aligned power, this time to the load, power at the load. again at the 3 dB gain compression point. And then we specify goals. And so we've set our goals for the power added efficiency to exceed 67% in this case. And our second goal is to exceed, to have output power delivered to load of at least 45 dBm. So that is what we do to set up the network synthesis. And now we'll move on to showing the results. Now we've moved straight to the tab with results from a previously run session. You can see those results here. The various topologies that were developed are in this table. We can sort based on the costs, how closely we met our synthesis goals. We can also sort by the number of components from the least number up to the most. And then we can toggle through and select different networks and look at a schematic of the simplified topology. We could see the first component is always that transmission line that we set in our criteria. And we'll be able to export this to Microwave Office, but include the automatic setup of some display options, the impedance of our matching network, as well as the performance in terms of its insertion loss. And the schematic is exported directly into Microwave Office based on which synthesis results I had selected in the table. And then I will have those available to me as solution sets that I can insert in my overall network and compare how they all perform versus each other. And as we can see, the synthesized impedance matching networks have all been designed with commercial components from our vendor library. And so we are that much closer to building a physically realizable PCB design. This concludes this demo on the new capabilities in network synthesis in version 15 of AWR Design Environment. For more information, visit the Cadence AWR microsite at awr.com or contact your local Cadence sales representative.